Now then, with the moving part stopped at point A, select Positioning Mode from Test Mode. Once the dialog box appears, click OK. Once the Move Distance Unit Selection dialog box appears, select Command Pulse Unit, Electronic Gear Valid, and then click OK. The Positioning Mode window should appear. Motor speed and acceleration-deceleration time constant should have the same values as those previously set. Now, I would like to describe the Move Distance setting. As the name implies, this setting sets the amount of movement. For this positioning control exercise, enter the actual distance of movement. Set Move Distance with a value of 4,194,304. Select the Stroke End is automatically turned on checkbox. Click the Reverse CW button. Once the dialog box appears, click OK. Then click the Reverse CW button again. The ball screw should have moved a little. The servo motor moved in the reverse CW direction by 4,194,304 pulses as instructed by the servo amplifier. Despite such a large number, the amount of movement is actually quite small. Next, let's set the electronic gear. From Parameter, select Parameter Setting, and then select Position Control. Click the Electronic Gear button. The Electronic Gear Setting dialog box appears. Find the Motor Encoder Resolution setting. 1,000 pulses per rev means that each motor rotation of 360 degrees is divided into 1,000 increments. Servo amplifiers output a signal once every pulse. As such, in this example, each pulse causes 0.36 degree of movement. In comparison to a clock, because the second hand of the clock rotates one rotation in 60 seconds, 360 degrees is divided into 60 increments. As such, the second hand moves 6 degrees for each tick. In this example, the servo amplifier moves 0.36 degree for each increment, which is obviously a much higher resolution than a clock. The resolution of the Mitsubishi Electric Mel Servo J4 is 4,194,304 pulses per revolution. This means that 360 degrees of rotation is divided into 4,194,304 increments. This means that this extremely high-precision device causes a mere 0.0008583,068 degree of movement with each pulse. Okay, let's go back and finish the setting. Select Number of Command Input Pulses per Revolution instead of Electronic Gear. Enter a value of 10,000 for the number of command input pulses per revolution setting. This sets the servo amplifier to divide each motor rotation into 10,000 pulses. After you have finished setting, it must be written into the servo. Once the dialog box appears, click Yes. Once writing has been completed, a dialog box appears indicating that the power to the servo amplifier needs to be turned off and on again. Click OK. Turn the power to the servo amplifier off and on again to reflect the setting. The positioning mode window appears again. Change the move distance setting from 4,194,304 to 10,000. Click the Reverse CW button. Once the dialog box appears, click OK. Then click the Reverse CW button again. The ball screw should have moved. The motor should have rotated in the reverse CW direction for one rotation. The ball screw used for this training moves 5 millimeters per motor rotation, so it should have moved 5 millimeters in the reverse CW direction. Now, let's perform control using a programmable controller. We have prepared a programmable controller sample program for use in this training. The sample program is stored on the accompanying disk. The disk includes IQR series, IQF series, Q series, L series, and F series versions of the program. Select the program compatible with your device. As you can see, sequence programs can be used together with the equipment to perform complex positioning control.